Hello Cyber Explorers, this is XK and welcome to Cyber Explore. In today's video, we'll talk about hash inversion or inverting hash values to the plaintext counterparts. This is as per a request from one of my viewers. So let's talk about it and... Wait a minute. You can't invert hashes. They're literally one-way functions. Thanks for watching. See you next time. Okay. Although you cannot technically invert hashes, there is a hack. I don't know why they call it inverting hashes. It is a brute force technique. In a nutshell, you calculate a ton of random hashes and store it in a large table or tables in the form of key value pairs like a dictionary. So next time you need a plain text for your hash, you return the value at the key defined by the same hash. The downside is you need lots of storage, and with longer hash functions like #512, it becomes infeasible for an individual to maintain such tables. That's where the online pre-computed tables stored in the cloud, calculated using multiple HPCs or high-performance cluster computers, come into handy. All you need is to paste the hash on the website's input box and it will show the result if it is already known to them, obviously. But we are engineers, so we like to automate them rather than opening a website, so we use an API. I found this website that offers free API access upon registration, which is also free and requires no credit card. So go ahead and register and get your API key. It is called md5decrypt.net. As the name suggests, you can decrypt MD5 hash. It also decrypts other hashes. Here is where you can find the API key after registration and successful email verification. Let's decrypt some hashes. Enough! Hey, Mr. or Mrs. Developer, are you out of your freaking mind? This is a hash, not a cipher. How can you decrypt this? MD5 is a hashing algorithm, not an encryption algorithm. What do you mean by md5decrypt.net? Okay, before calling me an idiot, I know there are hash functions that require a secret key. They are called keyed hash functions. There you get different results if you plug different keys. But it doesn't matter, as there is no unique inverse mapping and there is no concept of retrieval. Okay, calm down. Fine, I don't care what they're gonna call it, as long as it is working and it is free. If you have any confusion about my rant, please check out my video stating the difference between encryption and hashing. It will pop up on the top right corner where it's already uploaded, or wait till it is uploaded. Subscribe now so that you don't miss it. Let's go to Jupyter Notebook and begin the lab. As always, we have a separate section for the imports and the functions, and another one for the inputs. First, we define a function called the invert hash with the parameters hashval, which represents the hash value, and hash type, which denotes the hash algorithm, like MD5, SHA-1, SHA-256, NTLM, and so on. Since this is a REST API, we need to generate a request string before connecting to the server's endpoint. So let's do it first. We call it request string. This string consists of two components, the base URL, which is the link to the PHP web page, and the query. The question mark denotes the beginning of the query. The query consists of 4 parameters: the hash itself, the hash type, the email ID associated with your account, and the code, which is basically your API key. So we start by defining the base URL, which is this, and we construct our query like this. The first parameter, hash, is equal to our hashval from the function parameter. The ampersand used here is to append multiple parameters within the query. After this, we have the email, which is equal to the email, and the code is equal to the API key. But we don't have the email and the API key yet. So we go up and define a function called the fetchCreds, which will return email and the API key. We'll complete the function in a minute. But for now, let's assume we already have those 2 parameters. This means our request string is complete. We add a print statement so that we can see how it looks like when you run it for the first time. Now, we send this request string to the server using request.get function and receive the corresponding response. We need to import the requests library to make it work. We assume that some response is received, and we do a quick check using the if statement to ensure that. If the response status code is 200, it means that the server received our request and most likely sent a response. You can double check with the HTTP response codes. 200 means OK. But if it's not 200, we return it as invalid response. Now let's dig deeper into the valid territory. If the response text is not blank, it means there is some answer, which also includes some application-specific error codes that you can see on the table on the screen. This is as per the website, by the way. You can find the link in the description. Now we return the response text. But what if the response is blank? Well, it means there is nothing wrong in your request. It is just that the server has no information about the hash. So we return not found in the database. That marks the end of this function. For now, we are commenting this response section just to ensure we are not sending any garbage to the server on our first run. Next, we have to, of course, define the fetch credits function in a separate section before this. First, we open the file called credits0.txt in which the email and the API key are separated by a comma. We read it using the readline function and strip off any left or right white spaces to be on the safe side. We close the file as a good practice. You should always close the files. We split the string and store it in a list called cred list. The first entry corresponds to the email, and so we refer to credits list 0 and assign credit list 1 to the API key and return email and the API key. That's it. In the input section, we simply call the invert hash function with the parameters. I have a SHA-256 sample, so I copy and paste it along with the type. Call it result. And finally, print it. Now, as the primary function is depending on the fetch function, we must verify the extracted contents by printing the list. It works. You thought this is my real email and API key, didn't you? This is a different file. The actual credentials are in credits1.txt. Who do you think I am? A noob? Except that I initially opened the real file and I had to re-record this part. But hey, we all make mistakes. The key takeaways are the valuable lessons, which include not repeating the same mistake in any form. So follow in my footsteps. Fine. I changed the name to credits1.txt now and remove the print statements. See, I told you I learned from my mistakes. Now let's run it. Here you can see the request string containing all the parameters. Ah, shit. I take it back. Don't follow in my footsteps or you'll end up like this. Anyway, you have an idea how it looks like. Now I'm commenting this and running once again. Here is our output. Noob. That's me, I guess. And here's how you have to call the function if you want to use other hash algorithms. So that's it. If you need the code, you can find some of its pieces in the Github repositories, whose link you can find in the description. As usual, they are left intentionally incomplete for you as an assignment. Anyway, I hope you learned something about hash inversion using an online API in Python. Check out my hash generation video and the encryption playlist for more Python implementations. If you like this content, please show your love by hitting the like button and please subscribe for more content and in a way support my channel. I'll see you soon. Until then, stay safe and stay curious. Hey bro, today I decrypted a hash.
Say that again.